Okay, without further ado, we'd like to get started today. Thanks again for attending our webinar. Today we will be talking about test-driven development, or as Jeroen, our presenter later, will tell you, TDD, is it just a buzzword? That is the question today. Before we go into the content of the webinar, I would like to tell you a little bit more about iSQI, who we are, and some facts about our organization, just so you know a little bit more about our background, in case you're not familiar with iSQI yet. iSQI was founded about 15 years ago, and in the meantime we have grown to a global certification body where we work with organizations across the world in a number of areas, and the main background is software testing. And looking at the whole development of our program, you see that one of the areas, obviously Agile, has come into that play, and therefore today we will be looking a little bit more at the Agile teaming and Agile development. If I look at the exams, we do roughly about 143,000 exams so far since 2003, 25,000 to 30,000 a year at this moment, and across 6 continents, 100 languages, 100 languages, that would be beautiful obviously, but 10 languages and 100 countries. We have offices in the Netherlands, US, UK, and Germany. Our head office is in Potsdam, Germany, which is close to Berlin, for those who may not know where Potsdam is. UK, we're close to London. Netherlands, Amstelveen here, and Boston in the USA. A little bit more about who iSQI is and who we are as an organization. As I said, we're a global certification organization that works together with well-established training providers and boards in their area. And just a bit of an idea how this works. There are boards that take care of a program, in this case, for instance, iSQB. They work with an exam provider, such as iSQI, and we work with training providers. So together we form an environment creating the best opportunities and the best courses with the best certifications for professionals in the industry. So what kind of areas can you find us? As I said, we come from a software testing background, so iSTQB is a very big area for us. But software testing obviously has evolved into more wider areas. So we see areas like requirements engineering, the whole agile way of working. We see new things like DevOps coming into that, but also mobile working. And as you can see here, all these colored balloons, or balls if you want, depict different areas in which we are active and in which we have specialized. And it's also very, very versatile. You can see, for instance, business analysis as also an area that has been growing in our space, whereas software testing normally wasn't about business analysis, but where the business and the software development / testing are growing closer to each other, we see that there is a need for a wider portfolio and a wider specification. So if we look at Agile teaming is basically the area of Agile that we represent within the software space, starting at Certified Agile Essentials for people wanting to get to know a little bit more about Agile, getting the essential basics. Then we have a program which is very successful around the world called Certified Agile Tester. And we see that testers very more work in an environment that is an Agile DevOps Scrum team-like environment. And for this, they need to understand how it works in an Agile environment as a certified tester. So therefore, we see this. And in some countries, we have seen that this has become a standard and that organizations demand that candidates or professionals better have this certification. Certified Agile Business Analysis. I shortly hinted on that in when we were at the first slide, the previous slide. And business analysis has been becoming more important for Agile teams because of the business and the software development / testing coming closer to the business as is. And what we'll be talking today about is test-driven development, and I'm happy to see Jeroen on board as a master trainer in this area. So he's a specialist. He can tell you a lot more about this than I can. So he'll be with us in a second. Before we go into that content and before we ask Jeroen to take over, there are a couple of things that I would like to hint out. First of all participants are on mute, simply for the reason that that makes it much more enjoyable and easy to go through the webinar. But we can understand that you may have questions, and obviously we will be happy to answer your questions at the end of the section. We have a question and answer moment. So please enter your questions into the chat box, and we will see them as they come in. If you have any technical problems, also please use the checkbox, and there we have technical support who could help you to get going again. Our aim is to conclude the presentation within 30 minutes, so it doesn't take up too much of your time, but gives you the vital information that you would like to have. And the session is going to be recorded, so it will be made available later, so that you can go back to it and review it for your convenience at a later moment in time. Today, Jeroen Mengerink is our specialist, and I'll let Jeroen introduce himself in a second. But just a couple of words is that Jeroen is a master trainer in test-driven development and works with one of our very trusted advisors and partners in the Netherlands called Polteq. And the other presenter that you see there is Susanna Salem. Well, that's not me. Susanna was going to be the host on this session previously, but unfortunately she was unable to make it. My name is Frank Frambach. I'm the Managing Director for iSQI in the Netherlands, and happy to have hosted this part of the section for you. And at the end, I'll be back to do the questions together with Jeroen. And that is where I would like to hand over to Jeroen. So let me just quickly give him the opportunity to share his screen. Just one moment, please. So over to you, Jeroen.
Yes, thank you, Frank. I hope you can see my screen now.
Yeah, I see it perfectly well. Thank you.
Okay, so welcome everybody. As Frank said, my name is Jeroen Mengerink. I work for Polteq. I won't go into details about my background because I think you're here for content on TDD. TDD isn't just a buzzword, and that's the question we will answer today, or at least try to answer. Is it, or is it not? You hear it a lot, and with most terms that you hear a lot, it often is a buzzword, but let's see what we'll find out when we go through this webinar. First, a little bit content on what is TDD and about the red-green refactor cycle. Then I will go into a little bit of clean coding, solid principles, which we will get to, and then what I see at our customers and what I see in practice on how TDD is used. And then we will try to answer the question of if it's just a buzzword or not. So what is TDD? Well, test-driven development, that's what it stands for, and it is a software development process. So however the name starts with test, it is not a testing process, it's a software development process. So it's more closer to developers than it is to testers. And it's about the repetition of very short development cycles. So like we see with Agile Scrum, we break everything up in really small parts and try to make cycles where we increment our product. In this case, the software itself, the code. And it's about requirements that are turned into very specific test cases. So we create tests first, and then we create the implementation that actually is doing something on functionality for the application we are developing. So then the software is improved to pass the new tests only. And that's kind of the key. Only create that much software to pass the new test and then write another test. So don't go too far immediately. And the way we achieve that is by executing the red-green refactor cycle. There's one red arrow, and that is the only time in the process that a test can fail, should fail. So we write a test. That's where we start our development, and this test, of course, fails because there's no code yet to make it pass. So we're still in the red. Then we make a part of the software that passes the test. And after that, the tests will be green. All previously created tests should be green. If not, you've broken something that already worked before, and well, we cannot go on. We have to make a change in the code to make all tests green. And when we have all tests green, we enter the refactor phase. And in this phase, we try to optimize the code. We do not create new functionality. We do not create new tests. We try to improve our code. So be very aware that there's only the one red arrow is key in this cycle. In all the other instances, all tests that you've created should be green. So if there's a red test, you should be in the phase where you create code to pass that test. So you do not start refactoring your code or improving your code when a test is failing. So what is refactoring exactly? Well, it's restructuring your code without changing its external behavior. So you're improving the readability and and you're reducing the complexity to improve the maintainability of your code. And that's why all tests should remain passing, because we're not changing the external behavior of the code. So it's aimed at improving maintainability and creating a more expressive architecture to improve extensibility. And this includes proper naming. So refactoring could imply changing the names of functions, changing the names of variables, make your code better readable and therefore better maintainable. But it also includes removing parts of code that are duplicate and refactoring them and making a function to call that part of the code, so you not have duplicate code anywhere. Also to have better maintainability. So if you fix something in one place, it will be fixed everywhere and not just because there's duplicates just in one place where these bug could still occur at different places. All refactoring is actually done to create clean code. Readable, clean, proper code. So Clean Code is a book that's written by Robert C. Martin, under most developers also known as Uncle Bob. And it has some principles. The solid principles are in this book. So it's about single responsibility, OpenClosed Principle, Liskov substitution, interface segregation, and dependency inversion. To go into all of these principles in just 30 minutes, that will not fit. So I'll only deal with the first two. The rest of these, you can find stuff online about the principles, but it also dealt with in the TDD course that's provided by iSQI. Single responsibility principle. Well, to start with that, every module or class should have responsibility over a single part of the functionality. And it should be entirely encapsulated in that class. Well, to make it more tangible, if we have a class that deals with user management, this class should be about creating users, deleting users, updating users, finding users. It should do user management. So if we see an implementation that's something like this, it has a class user management with a create user, and it has a method send confirmation email. Send confirmation email does not belong with user management. Of course, we might want to have a confirmation email sent after we've created the user, but it's not a responsibility of the user management class to implement that. So what would be better would be a create user and a delete user and an update user in the user management class, and a different class that deals with the emailing. Of course, we can have a function call to that class at the end of the create user method. Well, if the user is properly created, we will send a confirmation email. but the responsibility of actually sending the email and the contents of that email should be in the mailer class. And this is where we separate the responsibilities into different classes with proper naming, so we actually know what you can find where. If we then again go to the OpenClosed principle, this deals with using inheritance of abstract base classes or compositions to reference other classes. So we have an interface closed to modification, but the implementation can differ. So it's open for extension and closed to modification. If we have a draw shape method that we give a shape, and we see this kind of code, if the shape is a circle, we call the method circle. If the shape is a triangle, we call the method draw triangle. Now, if we have a new shape, say a square, we should extend this and modify this method to be able to draw a square. So it's open for modification. We add a shape in a different class, and now we have to change this method. And that's not what we want. So we want to have open-closed properly introduced. We would have a draw shape, and then we call shape.draw. So the implementation of the drawing of a specific shape should be in the class that represents that shape. So they override a draw method, which is for all shapes, and it implements their own variety, their own version of that draw method. In this way, if we add a shape, this method never needs changing. The only change is in the class of that new shape that we add. And this is easier maintainable because the interface that uses draw shape or some other class that uses the draw shape method will still work, and it also works for the newly added shapes. So this is a little bit about the OpenClosed principle. So it's close to modification. We will not have to change this method again, but the implementation of this actual method can differ per other class of shape. So how is TDD used in practice? Well, that's quite different for all the customers I see and for all the developers I know. Some people try to implement it rigidly and do it continuously, TDD, test first, and then some small implementation. But what I mainly see is that developers use it to improve their coding skills. They practice at home or at some small project. They practice TDD to improve the way they code. Since the more and more they do TDD, creating tests first and then creating clean code to pass those tests, the more they internalize the proper way of coding, which reduces the amount of bugs and increases the readability and maintainability of their code. Another thing I see at customers is that they actually use TDD to fix bugs. Whenever a bug is found, a developer first creates a unit test to reproduce the bug, which of course fails the first step of the red-green practice cycle. So it's red because there is a bug that doesn't, that makes sure that the functionality is not doing what we want it to do. Then we fix the bug and rerun the test. Should now be green. We rerun all the tests and they should be green, and then we can probably refactor or change the code to make it even more maintainable. So this is one of the things I see more often in practice, that this is the part where TDD is actually used. And it is used to implement new functionality, but I haven't seen it practiced a lot yet. People try to do it. They only do it for very simple functionality or some algorithms, but not for complete new applications. And that is because it's really difficult to do this properly. It is not easy to practice this. You need a lot of retrying and reiterating on learning actually to do proper TDD. So that's why people use it to improve their coding skills and to fix bugs, but not that often to create new complex functionality. So what are we looking at now? Well, is it just a buzzword? Well, that's the question, right? We all want to know that. And well, I'm thinking on two parts. So yes, it is a buzzword because doing everything test first, that's most of the time is counterproductive. We go too slow. Managers don't want you to create tests and tests and tests. We want to do proof of concept, showing functionality fast, and creating all the tests. And of course, testing should be based on risks and return on investment. We do not need to test everything. And if we practice TDD by the book, it's test first and then develop something to pass that test. So everything is tested. And do we need that? Most people come to the conclusion that they don't, and they just do it for specific parts. So it's not a buzzword because people do use TDD to increase their development skills. Take a simple problem, maybe a problem where you already know the answer to on how to implement it, but then do a TDD. Create tests first, and then incrementally solve your problem. And then what you see is that sometimes when you start doing the TDD, you'll get to a different implementation than you thought that you would have. And often it's a better, shorter, or better maintainable implementation. And that comes together with the second point. TDD increases the testability of the code. Since we create a test first and then implement something to pass that test, we know that the part we implemented is testable because the test was already there. And it actually works as a safe line to make sure that when we change something in our code, we still know that everything works since we have the test. And it's not a buzzword if we use it as a tool to aid us in certain situations and not as a dogma. It's like with Agile Scrum. Agile Scrum is implemented in a lot of organizations, and every organization does it differently. Nobody actually completely does it by the book. And I think that's what we see with TDD as well. People choose their own way of implementing it, which is helpful for their specific context. So maybe to start out in your project, you will only use it to fix the bugs and make sure that you create a test first and then fix the bug. And then you do some sort of TDD in your project. And of course, we need practice. So you need to do this often and a lot and repeat the process of TDD to internalize it and make sure that you actually start doing it. So is it just a buzzword? In some cases, depends on how you interpret the word, it is, and in other cases, it's not. So are there any questions?
Hi, Jeroen. Thank you very much. That was a very clear presentation. Yes, we did receive a couple of questions. The first question I received is, do I need to be an experienced programmer to do TDD?
You need some experience in programming, but you don't need to be very experienced. Of course, you need to know how to create code and how to implement something. So to start with actually working test first and then adding functionality and making it clean as clean as possible, you only need some experience. But I think 1 year of development skill, 1 year of experience will be enough to start to benefit from learning TDD. So maybe it's not that you completely work TDD from then on, but it's like getting your driver's license. I passed my driving exam, then I know how to drive, but I still need to drive a lot to gain enough experience to drive well. And that's how it works with TDD as well. So if you start earlier, you have more time to learn. So I would recommend people to early in their development life start to get acquainted with TDD and start practicing with it.
Okay, very clear. Thanks. Another question that came in is, what is the most difficult when you start out doing TDD?
Well, that differs per person, but I think well, I've taught the TDD course now a couple of times, and the thing that people struggle a lot with differs on their background. On one hand, we have people that struggle a lot with defining the proper test cases to start with, and then implementing stuff. So maybe if you're a really good developer, you can implement it very fast, but thinking of the proper test cases is more difficult. And if you have more of a testing background, then you'll see that thinking of the test cases is quite easy, but implementing is harder. And then when you start implementing, it's like I said in the presentation, you will have to implement just enough to make the test pass. So we have to take baby steps in adding code. And that's really hard for people, because when you start implementing something to make the test pass, you already start to think about patterns and about more functionality that you want to add. And often people are tempted to add more code than is needed to make the test pass, which results in some parts of the code not being tested properly or thought of properly. So that's one of the harder things, to really force yourself to make baby steps in implementing your code.
Okay, thank you. Another question that we have is, if you look at the target audience, you said you have developed this course now, or delivered the course a number of times. Who is mainly the target audience? Is it the software tester? Is it the software developer? Or both, or neither? Or what can you tell us about that?
But the target audience for the TDD course is mainly developers, because it's a development practice. But we also see attendees that are test automation engineers, mainly people so testers that are really involved into developing as well. So I think we will see more and more people that are interesting from with a testing background as well, since they get closer to developers, maybe want to help doing the unit testing or reviewing unit tests and making sure that everything is done properly. So it's in basis it's aimed at developers, since TDD is a development practice, but we do see more and more testers with development affinity also join.
Wonderful, thank you very much. That was very clear, and that was also the last one of the questions that I had for now. Looking also at the time, we're just a minute short of the time that we had planned for today, 30 minutes, and no new questions coming in at the moment. I think it's time that we end the session. So I would like to very much thank you for your presentation, Jeroen. Thank all attendees for joining us today, and hopefully look forward to meeting you on one of our next webinars coming up soon.